All right, you guys, welcome back. So we were doing Riemann sum, and it's asking us some more questions about it. This is a very typical style question. This would be worth a point or two on the a point or two of raw score points on the test. So it says estimate R of 5, and so if we look at this graph, we see that we have R of 4 and R of 6. But we do not have R of 5. So we have R of 4 is equal to 190 gallons per hour. And we have R of 6, which is equal to 150 gallons per hour. We know the function is decreasing, but we don't know in what manner it's decreasing, okay? And so it's acceptable in this case to basically take the average of these two because we don't have any other information other than that it is decreasing, okay? So it's reasonable to say R of 5 would be approximately equal to, okay? Remember, this is an estimate. We don't know the exact value. We could make an argument it could be any possible number between 190 and 150 based on what they've told us. But in this case, it's reasonable to assume it's linear, in which case a simple average would be fine. So if I just take 190 plus 150 and divide that by 2, I would get 170 gallons per hour. It's perfectly reasonable to assume that. Okay. Now, earlier I scolded you and I said, hey, please don't connect the dots with a ruler. Okay. So right here at 5, we're looking here. I said, hey, don't use a ruler. And my concern there was that at these points, you'd have a break in the derivative. But in this case, it's okay to not worry about that and just say, hey, look, that's my best estimate of approximately how many gallons of oil were going into the tanker every hour. So there's my answer, 170 gallons per hour. When it tells you include units, that means this at least 1 point out of the 9 free response points, they're going to check your units. And what they do is they look on all of the answers. If it says include units, they're going to look on all of the answers. And if you don't put units on all of the answers, you miss one of them, they will deduct that point, which is unfortunate. Okay, then it says estimate R prime of 5. And so what this is asking us is a little bit different. What this is saying is what is the rate of change of the rate at which oil is going into the tanker, okay? So what they're saying here is basically what is the derivative of that at that point in time, okay? And so they're not asking for the value like they were before. The value of this function is is basically 170, but now they're saying, well, what's the rate of change of the rate of change? So it's asking us for the derivative of this. And so please just memorize that this is just f of b minus f of a over b minus a. So what we're saying is we have these 2 points here. At 4, we have 190, and at 6, we have 150. So essentially, this is the slope formula. And so what we're saying is this is A and this is B. And so this would be f of A and this would be f of B. It's just the slope formula. And so basically what it's saying is R prime of 5, our best estimate for the slope of that segment is to do f of B minus f of A. So 150 minus 190 over 6 minus 4. Okay, and so this is in gallons per hour. So this would be minus 40 gallons per hour over 2 hours. Okay, and those units do not cancel out. You end up with minus 20 gallons per hour squared. That's a perfectly acceptable way of writing it. You could also say minus 20 gallons per hour, okay? And I've included the units, but now it says explain its meaning within the context of the problem. And students often don't see that. They don't read what that says. So what that means is the oil is, the rate at which oil is going into the tank, the rate at which oil is pumped into the tank is decreasing. So the rate at which it is going into the tank is slower. Okay, and I talked about that. As the oil level gets higher, you have to pump the oil higher and higher and higher. It takes more energy to do that. So the rate at which the oil is pumped into the tank is decreasing by 20 gallons per hour per hour. Okay. Alrighty. Okay, remember, this is just repeating what we already knew to be true. The oil tank already had 1,000 gallons of oil in it. At time 0, oil is pumped into the tank at this rate model that's differentiable and decreasing on 0 to 10. Okay, before we move on and do the next problem, this is from your Wubby. And you guys, if I haven't mentioned it in class, your Wubby is the spiral-bound notebook, index cards. It's just a spiral-bound index cards, okay? A lot of people use them for recipes and things like that. You want to have a spiral-bound thing of note cards if you can get, or index cards, if you can get the kind with the plastic spindle or whatever, as opposed to the metal one. The metal ones I found get crushed once and then it never comes back to its correct shape, whereas the plastic ones seem to have a little flexibility. So these should go in your Wubby. You'll need to know these. The IVT, intermediate value theorem, it says if a function's continuous from A to B, and you choose some value in between. And so this is A on the x-axis, and this is B on the x-axis, and this is f of A, and this is f of B here. Okay, that's this value f of A and f of B. And what they're saying is that if n is some number between f of A and f of B, then there's some value of C that's on this interval where those will exactly match. F of C is equal to n. And it doesn't have to be differentiable. It could be any pattern as long as it's continuous. Okay, the mean value theorem, I think of M like slope. That's how I remember this one. This is basically just the slope formula. And what the mean value theorem says is that at some point on that interval, at least one point, it must be the case that the derivative is exactly equal to the overall rate of change. So if you have a graph, and it does from A to B, and the graph does something like this, what we're saying is whatever the slope of this is, which is your slope formula, has to be exactly equal to the slope of the tangent line at some value C. So we're just saying those two have to be parallel. Same exact slope. From geometry, this has to be parallel to this in at least one place. Okay, and what's weird about this one is I put an asterisk there. The function may have a vertical tangent at an endpoint without violating the mean value theorem. So, for instance, you could have a semicircle where your function looks something like this, and in that case, the rate of change would be 0, and this would be fine. You have a vertical tangent here, you have a vertical tangent here. The overall rate of change is 0, and therefore there must be one point where the derivative is 0. And that really applies more to Rolle's theorem. Rolle's theorem is just a special case of the mean value theorem. So for Rolle's theorem, I don't know a good way of remembering that. I visualize a tire just rolling down the street, and then I look at the tire, and I see the tire is in the shape of a great big 0. Okay, so I just think of it rolling down the street, a big 0. So what it's saying is if f of A equals f of B, so like I drew here, if the function's the same value at A and B, that means the overall rate of change is 0. And so therefore, there must be some point C at which the derivative is equal to 0. So it must have the horizontal tangent somewhere on that interval. Okay, all right, so then they will ask you a question like this. Okay, and it seems kind of out of left field, and you'll get accustomed to expecting these. Okay, when they give you a table of data, it is very common for them to ask you to apply one of these 3 theorems. Okay, so the first thing that I think of is it says r prime of t here, which tells me that we're talking about slope. Okay, this is the rate of change of something, and so right off the bat, I go to slope. And I think M, and I think this is going to be an instance of the mean value theorem, okay? Because it doesn't equal 0, I'm ruling out off the top of my head, I'm just going to rule out it being Rolle's theorem, okay? Now, intermediate value theorem, there could be a potential here for it to be the intermediate value theorem, but I'm going to go with my first hunch here and look for the mean value theorem and see if I can apply this. Okay, so what you have to do here is they're saying between 0 and 6, between times 0 and 6. So the low-hanging fruit here would be to try this one out and look at what is the rate of change between 0 and 6 on that interval. And the problem is that you have a rate, you have 100, it's decreasing by 100, and that is spread out over a 6-hour time interval. Okay, and so on the interval that they gave us from 0 to -6, I'm sorry, from 0 to 6, I end up with a negative 16.66, which is not exactly 18. And so what some students will do is they will jump and say, nope, it doesn't satisfy the mean value theorem. And you're right, it doesn't apply over this entire interval for certain, but you have to consider, what if I look within that that time interval? For instance, what if I look between 1 and 4 hours, which does fit on here. It is within here. If I go from 1 to 4, what's the rate of change there? Well, it's 50 divided by 3 hours. So I'd have a rate of change of 50 divided by 3 hours. So again, negative 16.66. So I'm not getting what I wanted to get. What I'm trying to do is find a way to get negative 18. And so with a little bit of poking around in here, 0 to 6 didn't work, 1 to 4 didn't work. What if I go from 1 to 6? Okay, so if I try between the time interval from 1 to 6, I'd have 150 minus 240 over 6 minus 1. Okay, and if I do that, 150 minus 240, I end up with negative 90 over 5. And if I divide that by 5, negative 90 divided by 5, sure enough, I get my negative 18. So there it is. Okay, I have found an interval over which this works. So just tell them by the mean value theorem, and it's okay to abbreviate that. Don't make up your own abbreviations on the test. I'll tell you which ones they allow. MVT, if you're worried that, if you're at all worried about that, just write it out. Okay, it'll take a few seconds of your time. Mean value theorem. Okay, I'm telling you, you don't need to write out mean value theorem. You can just write MVT. But on test day, you might forget what things you can abbreviate and which things you can't. So don't worry about it. It takes just a few seconds to write it out. They're going to give you a point for recognizing that it's the mean value theorem. Okay, and then the subinterval by the mean value theorem on the interval from what did he say? From 1 to 6, right? We know the average rate of change is negative 18 gallons per hour. So it must be the case. Running out of room for writing this down. We know the average rate of change is negative. The average rate is negative 18 gallons per hour. So it must be the case that the instantaneous rate of change is negative 18 gallons per hour somewhere on the interval from 1 to 6 hours. Okay, and you guys, you can use either form, either this or this form. They don't care. They don't care which way you do it. Okay, so make sure you state the theorem, make sure you state the interval on which you're looking, and state the value of the rate of change, and that will get you all of your points on that one. Okay, all right, guys. I will see you at the next video. Okay.